Section 10.3, continuity, problem number 11. We're determining whether the function is continuous at a given point. So here we have a case-defined function, or piecewise defined function, however you want to characterize it. F of x equals x plus 2 if x is greater than or equal to 2, and it equals x squared if x is less than 2. Okay, so, and then we're supposed to evaluate it at the points 2, 0. So looking at 2 first. So the function does have a value at 2. So we're only going to look at x plus 2 because that's the nature of this piecewise defined function, where you know x plus 2 is the form it takes if x is greater than or equal to 2. So f of a does exist there. Does the limit exist though as we're approaching 2? So as we're approaching 2 so the limit as x approaches 2 from the positive direction, we're going to have x plus 2, and that's going to equal 2 plus 2, which equals 4. And the limit as x approaches 2 from the negative direction is going to equal x squared, which is going to equal 2 squared, which equals 4. And so because these two are equal, then the limit does exist. And because the limit is equal to 4, which is equal to the function evaluated at 2, then the function, this piecewise defined function, is continuous at 2. So continuous at 2. Now let's look at 0. So for 0, so for just evaluating the function of f of 0, so let's look at 0 now. 0, so we're only going to look at x squared, and it is defined for x squared. 0 squared equals 0, so that's fine. Now let's look at the limit. As we approach 0 from the either side, we're going to basically be looking at x squared here. And so we're going to get the same answer no matter which side we're coming from, because x is defined for, so the function is defined for values less than 2 as x squared, right? That's the form it takes. And so we're getting infinitely close to 0 from both the right and the left hand side. And so we're going to be looking at numbers that are going to be less than 2 from the right side and the left side. And so we're going to get to the same limit regardless of the side we're coming from. And so the limit does exist at f equals 0, and it equals 0. So the limit as x approaches 0 of x squared equals 0, which is then equal to the function evaluated at 0. And so this piecewise defined function meets all 3 conditions of continuity, and thus the function is continuous at 0 as well.